Okay, today we're going to talk about log properties, and we're going to talk about three basic rules. There's addition, subtraction, and the power rules. There's also two actions we can take. That means what we can do with the log. So if you want to add it, sometimes you can expand it or you can condense it. So those are the two actions we can take. Now addition is pretty easy. You just have to have the same basis. So the basis, the number in front of the log before you add them must be 1. So here we have an invisible 1 here, while over here we have a 4. This one we can add and subtract as much as we want, but this one we cannot. We will have to do something to the 4. Okay, how do you actually do addition? Well, you take the 5 and the 2, the inside numbers of the log, and we're going to multiply them. So when you add, you multiply the 5 and the 2. So 5 times 2 is 10. So we have log base 3 of 5 and log base 3 of 6. And the inside numbers are 5 and 6. So 5 times 6, guys. Logs become 1 log. And therefore you have log base 3 of 30. What happens if you have variables, meaning letters? For example, you have log base 5 of x plus log base 5 of y. We follow the same rule. We take the insides, x and y, and we're going to multiply them. So x times y is just xy. Now that's the new inside of the new condensed log. And condensed, to be honest, is just another word for simplifying, because you're just making it from like large to small. Other weird stuff going on. By the way, the ln is just another form of log. It's log base e. We just have a shorthand, and so we write it as ln. So let's look what I did. I noticed that we were adding them, so x squared and c still multiply each other. And the two ln's become one single ln. And therefore you have ln of x squared times z. And that's it for that one. Now let's talk about the subtraction rule. It has the same requirements as addition. The bases must be the same, and the coefficient must be 1 in front of it. So in this case, this is my positive log, so 20 goes in the top of the fraction. And this is a minus log, so 4 goes in the bottom of the fraction. So when you condense it, it becomes 1 log, 20 in the top and 4 in the bottom, because it's minus log. Now we're actually going to simplify that, so 20 divided by 4 is 5. And again, this is the exact answer, now the approximated. So remember, ln is log base e, so it follows the same properties. 5 is from a positive ln, and 6 comes from a negative ln. So 5 should go in the top of the fraction, and 6 in the bottom of the fraction. And that's all you do. Now let's look at the power rule. It takes the coefficient, the number in front of the log, and moves it to the power of the inside number. So right here we have a 2 in front of the ln, and we have the inside number to be 6. So what's going to happen is we're going to take this 2 right here, and we're going to move it to the power of the 6. So you're going to end up with ln of 6 to the power of 2. Here, so 6 squared is 36, and that's how you work the power rule. Now let me show you some examples. If we take the 5 and move it to the top of the x, and then we have ln of x to the power of 5, and that's what you do. Now this is condensing also. We're going to move that 2 to the power over there. So we have log base 7, 5 to the power of 2. And we can simplify this because we know 5 squared is 25. So we end up with log base 7 of 25. And again, this is still condensing because we're making the log even simpler. Okay, let's talk about something special. What happens if the number in front of the log is a fraction? Well, a few things are going to happen. We need to, we're still going to follow the power rule. The power rule says move that 1/2 to the power. So 1/2 becomes the power of x. So we have log base 3 of x to the power 1/2. And what's going to happen is we're going to change this from rational form to radical form. So any rational exponents is the same thing as the square root of x. And we do prefer to have it the second way rather than the first way. Over here we have the power 1/3. I'm sorry, the coefficient of 1/3. It's going to become the power of 1/3. So we have y to the power of 1/3. And like the power of 1/2, 1/3 represents a radical. In this case, is the cube root. So put a little tree, a little house, and a y inside, and that's it. So when you're condensing, this is the basic rules usually you want to follow. Remove the coefficients in front of the logs first. So let's put this 2, -5, and move them up to the power. So x squared. The 3 is ln y cubed minus ln z 5, and of course we're going to ignore the negative because we're going to use it as a subtraction rule. So make a fraction, to make a decision, x goes on the top, y goes on the top, and z goes in the bottom, and that's it. They do go on the top together as multiplication. I notice we have 2 minuses now, okay, and 1 addition. But before, we need to get rid of our coefficients in the front of the numbers, of the logs. So 2, that's square. There's no coefficient there, so we're gonna just rewrite it. And there is a coefficient there, 6. So we're gonna say log base 3 x to the power of 6. Now, when you condense that, you're gonna write one single log base 3. And I'm gonna make a fraction. In this fraction, the 5 square is gonna go in the top because it's positive. So here's 5 squared. And then 7 is minus, so it goes in the bottom, and so does this. So 7. And when you put 2 in the bottom, they're still multiplying each other, but they're in the denominator. So that's where the negative comes from. And in this case, again, we do need to simplify. I do like my 5 squares for some reason. So you end up with 25 over 7x to the 6. And that is the exact answer of a condensed log. I do have a 1/2 in the front of this ln, and I do have a -2 in front of this ln. And the same thing here, we have a 2-piece combo going on over here. So let's see what I did. So let's 1/2, identify the coefficients. So when you condense, we always move the coefficients and make them the powers. Remember to not worry about the negative. And here's the thing, now the 2 really affects both pieces inside the log. So we're going to put the power outside the parentheses. And what should we really do is transform the power of 1/2 into a radical, but I don't know if I'm going to do it at the end or before. It doesn't really matter. Oh, no, I decided to make the fraction first. So what goes on top? X to the 1/2. And here we're going to apply some property. Y to the power 2 is, multiply the powers, 1 times 2 is 2, 2 times 7 is 14, so it's y squared z to the 14 because we must distribute the power to the other letters. And to be honest, I should have changed that 1/2 right here to the square root. Remember, the power 1/2 is equivalent to the square root. I should really have done that. Okay, now let's talk about the opposite of condensing. So before we were making things from big to small. What happens if they give it to you already reduced and you want to go backwards? So that process is called expanding. I noticed that I have x times z. So because it's times inside, we're going to do x squared plus ln of z cubed. And then now that we separated the ln's, the multiplications with addition, we're going to shoot the power down. So it's ln of x plus, I had the 3 in the front, right? And that's it. But I will have something like this. Well, log base 2. And let's distribute that power into the other ones so we can have one single separate entities. X to the 15. You end up with log base 2 x 10 and log base y, and then the power should have been in the 15. And then we're just going to shoot the power to the front. So let me just speed this up. So the 10 is in the front, and there you go. That's expanding going backwards. Okay, why if you have something like this? Well, first you need to know one basic property is the fact that if you have a square root over a fraction, you can separate the fraction and apply the square root independently of each other. So for example, that's the square root of x and that's the square root of y. That's properties of radicals. Then you have ln of x to the 1/2 and y to the power of 1/2. Because we do have a fraction inside and we were trying to expand it, the x is in the top, so we're going to have a positive ln. And the y is going to have a minus ln, or y to the 1/2. And we're just simply going to shoot the powers down to the front. So we have 1/2 x to the 1/2 ln over x minus ln of 1/2 ln of y. And that's technically your answer, although you could write it as ln of x over 2, because multiplying by 1/2 is the same thing as dividing, and ln of y equals to 2.